Hello, everyone. My name is Chanho from AH20 South Korea. I will present AR train combining SLAM with a marker detector for AR applications in static and dynamic environments. It is the roadmap. First, I will give introduction and related work of our research. Visual simultaneous localization and mapping SLAM technology is the process of creating a map of the surrounding environment while navigating it by camera images. Real-time visual SLAM approaches are suitable for augmented reality applications. However, most SLAM methods assume static environments, so it is difficult to augment the virtual objects on the dynamic environments. Recent researches have been proposed to add instance-level object detection module to track multiple moving objects. However, most object detection methods based on deep learning framework, which are time consuming, and the number of object classes is also limited. We propose a simple and efficient tracking system that integrates SLAM-based tracking module with a marker detector in static and dynamic environments. Based on the static map, our approach can localize the camera with SLAM-based tracking and simultaneously track markers attached to moving objects with a marker detector. And our system localizes camera and moving objects at the same time in the static map by unifying two different coordinate systems. Finally, the user can interact with the real world. Next, I will give an overview of our system. This is our system overview. It consists of 4 steps. Before the tracking, first, we prepare for tracking the environments. Next, our system tracks the static map using SLAM-based tracking module. And the dynamic environments attached to markers are tracked by the marker detector. Finally, considering scale factor, the static map, the camera, and moving objects can be represented into the same world coordinate system. Before the SLAM-based tracking module, we prepare for tracking the environments. First, our method requires a map of the static environments. We used ORB SLAM 2 to create the map in the static environments. And we add dynamic components with markers in the static environments. Next, our system tracks the static environments using the created static map. In SLAM-based tracking step, differently from the prepare step, uses ORB SLAM's localization mode. In this mode, the local mapping thread is deactivated, so this mode only localizes the camera in the static map without creating additional 3D map points. On the other hand, in the case of dynamic objects, features are not matched and ignored by SLAM-based tracking. Finally, we calculate the relationship between the SLAM map and camera coordinate systems. Next, our system has the ARCO marker detector to track moving objects. If the markers are detected in current frame, our system computes the relationship between camera and marker coordinate systems. If the markers are not detected, the system only tracks the static environments. And finally, our system unifies the 3 different coordinate systems. Let P map is a point in the SLAM map coordinate system, and P camera, P marker denote the points in the camera and the marker coordinate systems. Referring to the three coordinate systems in the figure, P map is R1 P camera plus T1, and P camera is R2 P marker plus T2. Here, the scale of the two coordinate systems, slab map and marker, is set to a same scale. Therefore, using equation 1 and 2, P map is R1, R2 P marker plus R1 T2 plus T1. The pose of the markers, then the pose of the markers can be represented in the same coordinate system as the 3D map points and the camera. And I will introduce our AR application. This is an example of an AR application. Based on our system, the static map and the dynamic components are tracked and expressed on the same coordinate system. Figure D shows that virtual objects are registered simultaneously in static and dynamic environments. I will show video of our application. In this demonstration, virtual objects are registered in the environments. In the case of toy train, it is a potentially movable object. Even if the train is moving, virtual smoke is registered accurately. In conclusion, we propose a simple method of combining the SLAM-based tracking module with a marker detector for AR applications. Our system performed localization of camera and the moving objects in the static environments. In future work, we will evaluate the trajectory of the camera and moving objects in the SLAM map coordinate system. Thank you for your attention.
Thank you, Chanho, for your presentation and your nice system. Maybe can you talk about a little bit about the limitation of your current system right now?
Limitation. Yes. We create limitations. We didn't measure the accuracy of camera and moving object trajectory, and we also did not measure the track time using the benchmark dataset. So we will evaluate them in the future, and we compare to the ground truth of the trajectory. And we created the static map with the RGBD camera, but we want to further study to create the only monocular camera. Yes.
Okay, thank you a lot, Chanho. I don't think we have a question coming from the chat. So I will thank you again, Chanho, and I think I will get back to you. Uh, we are a little bit beyond. Sorry about that. I was too much talking, but it was a great session, and we had a very great presenter and great talk. So thanks.